Hi everybody, welcome back. Just wanted to take a minute to walk through a few of your homework problems. Um, just that kind of the ones that may kind of maybe stump you a little bit along the way, or just to even show you a little bit more practice. So looking at problem number 2 right here, first thing we're being asked to state is the domain. So again, remember as your function falls down right now, it is going to keep continuing to spread out left and right. It's hard when you see these functions that are so straight up and down like this because you really start to almost get in your brain that it's not moving over. But truly, if you do keep zooming over, it does keep spreading out wider and wider left and right. The reason we just can't see it is because it is spreading out so slowly. So our domain really truly will be all real numbers here. As for our range, that one is a little bit easier to see. It does look like we're going to continue to keep hitting y values, or all possible y values. So we will see all real numbers for both of those two answers. Now, looking at the question of a relative min and a relative max. Looking at this, we don't exactly have one spot that's specifically a high point or a low point. Since we do have arrows on both ends, we do know our graph's going to kind of continue to keep going. So it really makes the only spot where we could potentially have relative max or min happen right in here. Now, since we see that really what's happening here is our graph is kind of increasing, and then it just slows its increasing down, but it does keep still increasing. And never had that spot where it switched from increasing to decreasing. And since that never happened, it means we don't have any relative maxes or any relative mins. So we will say none and none. Now, talking about where it is increasing, this graph actually appears to be increasing the entire amount of time. It is going up, 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 up. It does slow down, but it is still increasing. So this really increases on the interval of all real numbers, right? There is no spot where it's not increasing, which means there is no spot where it is decreasing, and there's also no spot where it is constant. Now, looking at the 0, remember again, the 0 is where your function crosses the x-axis, so I can see that point happening right there. We always list our zeros as points, so we will say 0, 0. And then the last part about this is symmetry, and this is probably the hardest idea because I think you got the weakest explanation on this part. But if you were to take this purple end of it and we actually were to rotate it down 180 degrees, we would see, in fact, that portion of our graph would match up perfectly on kind of this dotted portion down there. So since it does, in fact, have that rotational symmetry, we are able to say that this has odd symmetry. Odd is the word we use when something has rotational symmetry. About 0, 0, of course. Looking at problem number 3, again, we see a problem that does appear to be stretching out left and right. So we will say that our domain is all real numbers. Now, when it gets pushed to the side and we think about it that way, it appears we're going to kind of be pinched in between the values of -2 and +2. So that will be our range. So -2 to +2. In terms of any relative mins or maxes, now, again, looking at this problem, when I come up here, we do see that our function is increasing, but then that it switches to being constant. Remember, the only way to have a minimum or a maximum is really for your function to either be switching from increasing to decreasing or from decreasing to increasing. If it switches from increasing to constant or from decreasing to constant, that is not enough to say that you have a relative maximum. So in this situation, we have neither. So we don't have one of these, relative minimum, and we don't have a relative maximum. Now, in referring to where our function is increasing, decreasing, and constant, turning points are still a good spot to sit there and try to see if anything changes. So you could potentially put a line through this one too. But if you look at this, so I'm increasing on this interval and I'm also increasing on this interval, so this turning point didn't actually make a difference. I'm just increasing across that whole interval. Down to the bottom left here, we are constant over here because we are flat, right? Our graph is flat going out that way. and we're also constant up here. So we don't have any interval where we are decreasing, so we can simply say none there. But we are increasing from 2 all the way over to 4 here. So we will, or sorry, from -2. So increasing from -2 to 4. And then we are constant from -infinity to -2. That's referring to this portion. And also from 4 to +infinity. And that is, of course, referring to this portion. In looking for zeros, it does appear that we have a 0 that we can see right there. We did cross our x-axis. So we have a 0 at 2, 0. And then as far as your symmetry goes, this one does not have any rotational symmetry, and it certainly is not symmetrical about the y-axis, so we will say this has none. Let's do one more problem together. We'll do problem number 4 here, and then your homework assignment's probably going to basically be the last 3 of those problems. Looking at this first one, looking at problem number 4. As for your domain, this one again spreads out left and right, and it does keep spreading out. It just gets hard to see because we're seeing such a zoomed in picture of it, but it will keep spreading out left and right. So our domain will in fact be all real numbers. As for our range, it looks like we do hit a high point and then it continues to drop down. So our range would be from -infinity all the way up to 0. Looking at our relative mins and maxes, we do see that we will have a relative max, a second relative max, and here we have a relative minimum. Our relative minimum appears to be happening at 1.5, -5. Our relative maxes appear to happen at 0, 0, and also at 3, 0. Now, again, to identify where your function is increasing or decreasing, if you draw a little vertical line through your relative mins and maxes, that's sometimes a good indicator. Remember, we are always reading this from left to right, so in that situation, we are increasing. I'm going to put an I. In this interval, we are going downhill, so we are decreasing, so I'll put a D. Then we are increasing from there to there, so I'll put an I, and finally, the last section of that, we will be decreasing. So we don't have any spots where we are constant. As for our increasing interval, -infinity to 0 is what that would be. And then we're also increasing from 1.5 to 3, so I can say 1.5 all the way over to 3. Our decreasing intervals are going to happen from, really they're happening between 0 and 1.5. And then also we are decreasing from 3 to infinity. Our zeros are just where we are crossing our x-axis, so we have one here and one there. So we'll have zeros at 0, 0, and also at 3, 0. And then in terms of symmetry, now while this does appear to be symmetrical, if my dividing line was right here, our dividing line, in order for us to say if this is even or odd, has to be right here. So since we are not symmetrical about the solid pink line, we will say that this does not have any symmetry. I hope this was helpful and gave you just a few more problems to kind of practice on. You do, it looks like, have 3 more problems to sit there and complete on this worksheet. Again, if you have questions, please don't hesitate to reach out. Have a great day.